Are we alone in the universe, or could there be civilizations so advanced they've been watching us all along, not as equals, but as something far more unsettling? Picture this: Earth as a giant exhibit, humanity under silent observation, our every move studied by beings who choose to remain hidden. It sounds like science fiction, but this is the spine-tingling premise of the zoo hypothesis, one of the most provocative ideas in the search for extraterrestrial intelligence. What if aliens aren't just out there but have deliberately avoided contact, treating our planet like a cosmic wildlife preserve? The theory suggests we might not be the apex creatures we believe ourselves to be instead. We could be the subjects of an experiment, or worse, a spectacle. Think about how we study animals in nature. Scientists observe from a distance, careful not to disrupt the habitat, documenting behaviors without interference. Now flip that scenario. What if we're the ones behind the glass? The zoo hypothesis proposes that advanced civilizations might see us as too primitive, too volatile, or too valuable to disturb. They could be waiting for humanity to reach a certain milestone, technological, ethical, or even spiritual, before making contact. Or perhaps they've already deemed us unworthy of conversation, leaving us to evolve in isolation. The chilling elegance of this idea isn't just in its mystery, but in the questions it forces us to confront. If we're being watched, why? And what would it mean for our future if the observers finally decided to step into the light? This isn't just wild speculation. The zoo hypothesis has roots in serious scientific discourse, sparked by the unsettling silence of the cosmos. Despite decades scanning the stars, we've found no definitive proof of alien life. No signals, no artifacts, no visitors. But absence of evidence isn't evidence of absence. Could the great silence itself be the clue? From the Fermi Paradox to modern astrobiological research, the possibility that we're part of a galactic conservation project lingers like a shadow. In this video, we'll unravel the layers of this theory, exploring the eerie evidence that supports it, the arguments against it, and what it reveals about humanity's place in the universe. Strap in, because by the end, you might never look at the night sky the same way again. The idea that we might be living in a galactic zoo didn't emerge from nowhere. It came from a time when humanity was grappling with its own existential fears. In 1973, astronomer John Ball put forward a radical explanation for one of science's greatest mysteries, Fermi's paradox. You know the question: if the universe is so vast and ancient, with countless stars and planets, where are all the aliens? Ball's answer was chillingly elegant. Maybe they're right here, watching us, but choosing to stay hidden. At the time, the world was deep in the Cold War, a period of nuclear tension and ideological division. The threat of self-destruction loomed large, and it made people wonder, if intelligent life existed elsewhere, could it have survived its own technological adolescence? Ball's zoo hypothesis suggested that advanced civilizations might see us the way we see uncontacted tribes in the Amazon, fascinating but fragile. Interference could be disastrous, so they keep their distance, observing from the shadows until we're ready. This wasn't just a wild guess. Ball connected it to a long-standing puzzle in astronomy. Despite decades of searching, we'd found no signs of alien visitors, no radio signals, no megastructures, just silence. That eerie absence lined up perfectly with the idea that someone or something was deliberately keeping quiet. And in an era when humanity was staring down the barrel of its own destructive potential, the notion that we might be quarantined for our own good or someone else's didn't seem so far-fetched. The Cold War context is key. Think about it: nations spying on each other, the constant dread of mutual annihilation, the fear that any wrong move could trigger catastrophe. In that climate, the idea of hidden observers wasn't just scientific speculation. It was a mirror held up to human behavior. If we were capable of such secrecy and caution, why wouldn't a far older, wiser species do the same? Ball's hypothesis forced people to confront an unsettling possibility. Maybe we weren't being ignored, maybe we were being managed. Enrico Fermi, the brilliant physicist who helped pioneer the atomic age, once posed a question over lunch that would haunt scientists for decades. If the universe is teeming with potential life, why haven't we seen any signs of it? This simple observation, now known as Fermi's paradox, cuts to the heart of our cosmic loneliness. Statistically, the numbers are staggering: billions of stars, many with planets in the habitable zone, and billions more years for civilizations to arise. And yet, the sky remains silent, no distant cities glittering on exoplanets, no interstellar probes drifting through our solar system, just silence. One possible answer lies in the zoo hypothesis. Imagine a universe where advanced civilizations aren't missing, they're deliberately staying out of sight. Like game wardens in a vast galactic preserve, they might be enforcing a strict policy of non-interference, ensuring younger species like ours evolve without outside influence. This wouldn't be altruism, it could be protocol. After all, humanity's own track record with less technologically developed societies isn't exactly stellar. From colonization to cultural erasure, first contact has rarely gone well for the less advanced party. An older, wiser civilization might see us as too unpredictable, too dangerous to engage with directly. There's another chilling possibility. What if we're not just quarantined but irrelevant? To a civilization millions of years ahead of us, we might be little more than ants beneath a microscope. They could be so far beyond our comprehension that communication is pointless, like us trying to debate philosophy with a bacterium. Or worse, they might view Earth as nothing more than a curiosity, a cosmic petri dish left to simmer until something interesting emerges. The Great Silence itself becomes evidence under this theory. The fact that we haven't detected any signals or artifacts might not be a fluke, but proof of a deliberate effort to remain unseen. After all, if a civilization wanted to observe without influencing, they wouldn't leave obvious traces. They'd mask their presence, possibly using technology we can't even conceive of yet. This idea flips Fermi's question on its head. Instead of asking why we haven't found aliens, we're forced to ask, what if the reason we haven't found them is because they don't want to be found? Some scientists argue this could explain the eerie absence of megastructures like Dyson spheres, theoretical energy harvesting constructs built around stars. If such projects exist, they'd be detectable from vast distances, yet we see none. Maybe advanced civilizations don't build outward because they've mastered subtler, more efficient technologies. Or maybe they're deliberately avoiding anything flashy, maintaining a low profile to keep their cosmic zoo intact. The implications are profound. If the zoo hypothesis is correct, then every radio signal we've ever broadcast, every satellite we've launched, every nuclear test we've conducted could be meticulously recorded in some vast alien archive. Our entire history might be nothing more than an entry in their database, a case study of a species fumbling toward maturity, unaware of the unseen eyes tracking our every step. It's a humbling thought, one that forces us to reconsider not just our place in the universe, but the very nature of intelligence itself. What if the silence from the stars isn't neglect, but restraint? The zoo hypothesis takes on an ethical dimension when we consider that advanced civilizations might operate by a code, one that prioritizes preservation over curiosity. Imagine a galaxy where the most powerful beings see themselves not as conquerors but as caretakers. This isn't just speculation, it mirrors our own evolving approach to conservation here on Earth. Take the Sentinelese people of the Andaman Islands, for example. Despite having the technology to reach them, modern societies have chosen to leave this isolated tribe undisturbed. Governments enforce strict no-contact policies, recognizing that interference could devastate their culture, introduce deadly diseases, or disrupt their way of life. Now scale that up to a cosmic level. a civilization a million years ahead of us might view Earth with the same cautious respect, not out of fear, but out of wisdom. The parallels run deeper. Ecologists speak of the observer effect, how even passive monitoring can alter an ecosystem. Scientists studying wildlife often use hidden cameras or remote sensors to minimize their footprint. If a highly advanced species has studied the rise and fall of countless civilizations, they might have learned the hard way that contact does more harm than good. Ancient ruins across our own planet tell grim stories of what happens when technologically superior societies collide with less advanced ones. The same ethical calculus could persuade alien observers to keep their distance until we bridge the gap ourselves. But there's a darker interpretation. What if their restraint isn't altruistic but pragmatic? A civilization that survived for millennia would understand the dangers of unchecked expansion. Just as we've established marine reserves to protect fragile ecosystems, they might designate planets like Earth as off-limits, not for our benefit but to preserve the cosmic balance. Fermi's paradox might not be a question of their absence but of their discipline. The unsettling truth is, we have no way of knowing their motives. Their ethics could be as incomprehensible to us as our environmental laws would be to a Bronze Age farmer. Yet one thing is clear. If the zoo hypothesis is correct, humanity's loudest achievements, our radio transmissions, our space probes, our nuclear tests, might be nothing more than background noise in a universe where the truly advanced have learned the value of silence. Science fiction often mirrors our deepest scientific curiosities, and nowhere is this more striking than in Star Trek's Prime Directive, a concept that feels ripped straight from the zoo hypothesis playbook. In the Star Trek universe, Starfleet's most sacred rule forbids interference with pre-warp civilizations, no matter how noble the intentions, the reasoning. Contact could disrupt natural social evolution, introduce destabilizing technology, or even accidentally erase entire cultures. Sound familiar? It's a fictional echo of the very ethical dilemmas posed by the zoo hypothesis, blurring the line between speculative storytelling and serious astrobiological theory. The parallels run deeper than mere coincidence. Both ideas grapple with a fundamental question: how should advanced beings interact with those still finding their footing? In Star Trek, breaking the Prime Directive leads to chaos. Cultures collapse, wars ignite, and societies lose their autonomy. The show's writers drew inspiration from real-world colonial history, where well-intentioned interventions often spawned unintended catastrophes. The zoo hypothesis suggests that hypothetical alien observers might have arrived at the same conclusion millennia ago, treating Earth like Starfleet treats a pre-warp planet, observed but untouched. But here's where reality diverges from fiction. The Prime Directive assumes a centralized authority enforcing these rules, while the zoo hypothesis operates on a cosmic scale with no visible enforcers. If aliens are out there adhering to their own version of non-interference, how do they coordinate it? Would every advanced civilization independently reach the same ethical conclusion? Or is there some unseen galactic governance ensuring the rules are followed? The silence we perceive might not just be restraint. It could be a universal consensus, a silent treaty among civilizations older than our planet. Pop culture's fascination with these themes reveals something telling about humanity's own anxieties. From the Twilight Zone to Arrival, stories about hidden observers or delayed contact tap into our fear of insignificance, or worse, of being judged. The Prime Directive isn't just a plot device. It's a mirror held up to our own history of exploitation and the lingering guilt over cultures disrupted in the name of progress. The zoo hypothesis forces us to confront an uncomfortable truth. If we ever do meet aliens, we might not be the heroes of the story. We could be the pre-warp civilization, the ones deemed too fragile for inclusion in the galactic community. Yet there's a twist. Star Trek eventually shows civilizations graduating from protection once they develop warp drive. They're ready for the interstellar stage. Could the same be true for us? Some versions of the zoo hypothesis suggest aliens might break their silence once we hit a specific technological or ethical milestone, like harnessing clean energy or abandoning warfare. It's a hopeful counterpoint to the eerie idea of perpetual observation, implying that the cosmic curtain might lift, but only when we prove we're ready. The irony is delicious. A sci-fi TV series from the 1960s might hold the key to understanding why advanced aliens would leave us alone, while real-world scientists debate the same premise with equations and radio telescopes. Whether through storytelling or science, humanity keeps circling back to the same profound uncertainty. Are we being watched, and if so, what are they waiting for? The answer might lie not in distant stars, but in how we navigate our own planet's next chapter. Consider this unsettling thought. What if alien civilizations are all around us, but their technology operates on principles so far beyond our understanding that we literally can't perceive them? To a house ant, a Wi-Fi signal is invisible. A smartphone is just a shiny rock. The ant's world is confined to what its biology and crude senses can interpret, completely blind to the vast digital networks humming right above its antennae. Now imagine humanity as that ant colony, oblivious to technologies that might be monitoring us from plain sight. This isn't just philosophical musing, it's a legitimate scientific hurdle in the search for extraterrestrial intelligence. Take Dyson spheres, for example. These hypothetical megastructures, first proposed by physicist Freeman Dyson in the 1960s, would encapsulate entire stars to harness their energy. A civilization capable of building one would operate on a scale we can barely fathom. Yet if such a thing existed in our cosmic neighborhood, would we even recognize it? Our telescopes look for heat signatures and light patterns that fit our narrow expectations. A Dyson sphere might emit waste heat in forms we don't know how to detect, or use energy so efficiently it leaves no trace at all. We could be staring right at one and mistake it for a distant gas cloud. Then there's the possibility of stealth probes, NASA Voyager spacecraft, humanity's farthest flung artifacts, are crude metal boxes compared to what an advanced species might deploy. Imagine self-replicating nanomachines smaller than a grain of sand, scattered across galaxies like cosmic pollen. These could be observing Earth right now, camouflaged as space dust or even integrated into our own technology. After all, if you handed a medieval scholar a modern microchip, they'd assume it was a peculiar pebble. Our best detection methods rely on finding things that match our current scientific framework. But what if alien tech operates outside physics as we know it? The challenge runs deeper than hardware. Communication itself might be the barrier. We scour the cosmos for radio waves, the same technology we've used for barely over a century. An older civilization could have long abandoned such primitive methods, using quantum entanglement, neutrino beams, or something beyond our lexicon entirely. It's like searching for smoke signals in an age of fiber optics. The silence doesn't mean no one's talking, just that we're listening for the wrong things. Even time itself could distort our perception. A species millions of years ahead of us might not operate on human timescales. Their observation missions could span millennia, their probes programmed to awaken only when we reach certain milestones. To them, our entire recorded history, from pyramids to space stations, might be a brief flicker in a long-term study. Meanwhile, we're left staring at static, unaware that the real conversation happens in dimensions we can't access. The sobering truth is this: absence of evidence isn't evidence of absence. Our inability to detect advanced life might say more about our limitations than theirs. Every breakthrough in physics, from relativity to quantum mechanics, has revealed layers of reality previously unimaginable. Who's to say the next won't expose an entire galactic community operating just beyond our senses? The universe isn't obligated to make itself comprehensible to a species that's only been doing science for a few hundred years. If the zoo hypothesis is correct, the greatest cosmic joke might be that the watchers were here all along, waiting for us to invent the tools to notice them. Could those mysterious lights in the sky be more than just misidentified aircraft or atmospheric phenomena? What if UFOs aren't random anomalies at all, but deliberate glimpses, carefully orchestrated peeks behind the cosmic curtain? The zoo hypothesis takes on a new dimension when we consider that some UFO encounters might not be accidents, but controlled experiments by advanced observers testing human reactions without blowing their cover. Declassified government reports add fuel to this eerie possibility. Take the U.S. Pentagon's 2021 UFO assessment, which openly acknowledged 144 incidents involving unidentified aerial phenomena, 80 of which were captured on multiple sensors. These weren't blurry, grainy photos. They included objects maneuvering in ways that defy known physics, with no visible propulsion systems or flight surfaces. The most chilling detail, the report explicitly ruled out secret U.S. technology, leaving the door wide open for other explanations. This ambiguity is exactly what you'd expect if the zoo hypothesis were true. Imagine an alien civilization that wants to study us without triggering mass panic or cultural disruption. Dropping a cloaked probe into our airspace for a few seconds, long enough to gauge military responses or public reactions, would be like a biologist briefly lifting a rock to observe insects before carefully replacing it. The occasional leak, like the infamous 1952 Washington, D.C. UFO flap or the 2023 Chinese balloon incident, could serve as data points in a long-term behavioral study. Even the inconsistent nature of sightings fits this model, sporadic enough to avoid confirmation but persistent enough to keep us guessing. Historical accounts add layers to this puzzle. Consider the 1947 Roswell incident, where military officials first claimed to recover a flying disc, only to retract the statement hours later. Or the 1986 Japan Airlines Flight 1628 encounter, where pilots reported a massive unidentified object trailing their plane over Alaska, corroborated by air traffic control radar. These cases share a common thread: credible witnesses, physical evidence, followed by official explanations that feel incomplete. If these were deliberate displays, their purpose might not be contact, but calibration, testing how governments, media, and the public process the inexplicable. The psychological impact of such staged encounters can't be ignored. Societies that experience UFO waves often undergo predictable cycles: initial fascination, followed by fervent speculation, then either dismissal or subculture obsession. This pattern mirrors controlled exposure experiments in social science, where researchers introduce stimuli to observe group dynamics. An alien species monitoring Earth might view these reactions as critical data, measuring everything from our analytical capabilities to our capacity for collective fear or wonder. Yet there's a counter-argument. If UFOs are surveillance tools, why allow any visibility at all? Advanced observers could easily remain entirely undetectable. Maybe the sightings aren't planned, but inevitable, like zoo animals occasionally spotting the edge of their enclosure. Or perhaps these leaks serve a dual purpose, not just gathering data, but gently acclimating humanity to the idea that we're not alone, like turning up the dimmer switch on cosmic revelation, one flicker at a time. The real bombshell lies in what we don't see. Despite 75 years of modern UFO reports, there's still no irrefutable proof, no alien artifact on display in a museum, no unambiguous message. That absence might be the most telling evidence of all. If the zoo hypothesis is correct, the ambiguity itself is the message. We're being given just enough to wonder, but never enough to know. The phenomenon dangles at the edge of our perception, ensuring we remain forever on the precipice of discovery, never falling in, never turning away. A perfect equilibrium for observers who want neither to hide completely nor reveal themselves fully. Whether these mysterious crafts belong to extraterrestrial scientists or simply reflect our own technological blind spots, one thing's certain: every unexplained radar blip, every pilot's stunned testimony, every government report that concludes inconclusive deepens the enigma. The skies may not be silent after all. They might be whispering in a language we're only beginning to decipher. Imagine waking up one day to definitive proof that we've never been alone, that every war, every invention, every whispered thought under the stars was recorded by unseen observers. How would that revelation reshape what it means to be human? The zoo hypothesis doesn't just speculate about alien behavior. It holds up a mirror to our deepest existential fears and aspirations. If we're specimens in some grand cosmic study, does that diminish our achievements or make them more remarkable? At first glance, the idea of being watched could trigger a primal sense of violation, like lab rats in an invisible cage. Humanity prides itself on autonomy, the belief that our choices shape destiny. But under the zoo hypothesis, even our greatest moments of ingenuity might be predetermined data points in an alien research project. The pyramids, the moon landing, the internet. What if these weren't leaps of progress, but expected milestones in a controlled experiment? Psychologists call this the observer effect on a species-wide scale. The mere awareness of being watched alters behavior. Would we still strive, create, or rebel if we knew our actions were being catalogued by entities who see us as curiosities rather than peers? Yet there's another way to frame it. In nature preserves, rangers don't interfere because they recognize the intrinsic value of ecosystems, not out of condescension, but reverence. If advanced civilizations are leaving us undisturbed, it might signal respect for our potential rather than indifference. After all, we don't intrude on uncontacted tribes because we deem them inferior, but because we acknowledge their right to self-determination. This interpretation flips the script. Instead of feeling like test subjects, we might see ourselves as seedlings in a galactic greenhouse, given space to grow until we're ready for larger truths. Philosophers have wrestled with similar questions for centuries. The 18th century thinker Immanuel Kant argued that reality is fundamentally shaped by the limits of human perception, that we can never know things as they truly are, only as our minds interpret them. The zoo hypothesis takes this idea to cosmic extremes. If aliens exist beyond our perceptual and cognitive limits, their motives might be as incomprehensible to us as a librarian's cataloging system is to an ant crawling across a book's spine. Our entire understanding of purpose, free will, and meaning could be built on assumptions that don't apply outside Earth's intellectual bubble. History offers sobering parallels. When European explorers first encountered isolated indigenous cultures, the shock of realizing they weren't alone in the world triggered existential crises. Entire cosmologies collapsed overnight. Now imagine that dislocation magnified to a planetary scale. Religions might reinterpret deities as alien observers. Political ideologies could fracture over whether to seek contact or resist it. Even science, our most trusted tool for understanding reality, would face radical upheaval if the rules we've discovered turn out to be local bylaws in a universe with vastly deeper laws. But here's the twist: the very act of grappling with these questions proves why humanity might be worth observing. Our capacity for self-reflection, to doubt, wonder, and reinterpret our place in the cosmos, is arguably what sets us apart from other earthly species. A civilization capable of hiding in plain sight would likely recognize this trait. They might view our existential angst not as naivety, but as the first stirrings of maturity. After all, a wolf doesn't question its role in the forest. A bacterium doesn't ponder morality. The fact that we can even entertain the zoo hypothesis suggests we're already knocking on the door of a broader cosmic perspective. Perhaps the ultimate test isn't whether we're being watched, but how we respond to the possibility. Do we succumb to paranoia, seeing every unexplained phenomenon as evidence of manipulation? Or do we channel that awareness into growth, treating Earth as the precious anomaly it might be, a rare garden of self-aware life in a silent universe? The zoo hypothesis forces us to confront our own contradictions, our longing for cosmic companionship, and our terror of being insignificant. In that tension lies the most human thing of all, the relentless, uneasy quest to understand what we are and what we might yet become. What if the zoo hypothesis isn't just about biological observers, but about something far more abstract: aliens as architects of our very reality? This is where the lines blur between cosmic surveillance and simulation theory, the provocative idea that our universe might be an artificial construct. Think of it as the zoo hypothesis on steroids. Instead of aliens quietly watching from behind some interstellar one-way mirror, they could be the unseen programmers of the simulation we call existence. Elon Musk famously leaned into this idea, stating that the odds we're living in base reality are 1 in billions. But this isn't just Silicon Valley speculation. It's a debate with roots in philosophy, physics, and now astrobiology. Simulation theory shares eerie common ground with the zoo hypothesis. Both suggest a higher intelligence manipulating our environment, whether by design or discretion. In one scenario, aliens avoid contact to preserve our natural development. In the other, they've built the entire framework of our reality, rendering contact irrelevant because they're not out there, they're in the code. The chilling similarity: in both cases, humanity's autonomy might be an illusion. Just as zookeepers control the habitat of their animals, simulation architects could dictate the boundaries of our perceived universe without us ever knowing. The scientific underpinnings of this overlap are stranger than fiction. Oxford philosopher Nick Bostrom's seminal 2003 paper laid out the trippy logic. If advanced civilizations can run ancestor simulations, hyper-realistic recreations of their past, the statistical likelihood we're in the original timeline shrinks to near zero. Now fuse that with the zoo hypothesis. What if those simulations aren't just historical recreations, but ethical experiments? A civilization might create countless simulated worlds to study consciousness, societal evolution, or even moral dilemmas, treating each like a cosmic petri dish. Earth could be one of billions of running experiments, observed not through telescopes but through the very fabric of our programmed reality. Critics push back with hard questions. If we're in a simulation, where's the glitchy evidence? Proponents counter that any advanced system would self-correct like a video game, patching bugs before players notice. Even the zoo hypothesis faces similar scrutiny. If aliens are hiding, why no slip-ups? But here's where the theories diverge compellingly. Simulation theory suggests we might never find aliens because they exist outside our simulation's rendered distance. The cosmic silence isn't about restraint, it's about hardware limitations. Meanwhile, the zoo hypothesis implies they're physically present but cloaked. Both explain Fermi's paradox, but through radically different lenses. Musk's 1,000,000-to-1 odds argument taps into a deeper anxiety, the unnerving scale of technological ascent. Civilizations just a few thousand years ahead of us could harness energies making stars look like campfires. So why wouldn't they run simulations? The zoo hypothesis adds a layer. Maybe they're not just simulating worlds, but curating them. Like a game developer tweaking variables to test outcomes, our alien programmers might adjust Earth's parameters to study resilience, creativity, or self-destruction. Climate change, nuclear war, pandemics, these could be deliberate stress tests in a grand cosmic lab. Yet the most mind-bending twist is ethical. If the zoo hypothesis assumes aliens avoid contact to prevent harm, simulation theory inverts that logic. Our suffering might be the point data points in a study on adversity, or conversely, our joys could be the experiment's purpose. Either way, the implications haunt. Are human rights sacred, or just lines of code to our creators? Does free will exist, or are we NPCs in someone else's story? These questions aren't new. They echo religious debates about predestination. but now they're framed in quantum physics and machine logic. The terrifying beauty of these ideas is their unfalsifiability. Like gods hiding in quantum uncertainty, alien observers or simulation architects could always be one step beyond detection. That's why scientists like astrophysicist Neil deGrasse Tyson urge caution without evidence. These remain thought experiments, not theories, but thought experiments shape history. Copernicus moving Earth from the universe's center was once heresy. Darwin's evolution upended human exceptionalism. Today, the zoo hypothesis and simulation theory challenge our sovereignty over reality itself. Whether we're animals in a galactic zoo or characters in an alien simulation, the message is the same. We might not be who or what we think we are. For decades, SETI, the search for extraterrestrial intelligence, has trained its antennas on the stars, listening intently for the faintest whisper of an alien radio signal. It's a noble effort, one born from optimism and the belief that any advanced civilization would, like us, use radio waves to communicate across the void. But here's the uncomfortable question. What if we're searching the wrong channels? If the zoo hypothesis holds water and advanced civilizations are deliberately avoiding contact, then SETI's traditional approach might be like trying to catch a whisper in a hurricane. The very methods we've relied on could be doomed to fail, not because aliens aren't out there, but because they've chosen silence as protocol. Consider the limitations of radio signals. Humanity has only been broadcasting for about 120 years, a blink in cosmic time. Our earliest transmissions, like the 1936 Berlin Olympics broadcast, have barely traveled 100 light years. In a galaxy over 100,000 light-years wide, that's a shockingly small bubble. Even if civilizations were common, the odds of overlapping our technological window with theirs are vanishingly slim. But the deeper issue is this: radio is primitive, it's messy, inefficient, and fades over distance. A civilization just a few thousand years ahead of us might have abandoned radio entirely, using technologies we can't yet conceive. Quantum communication, dark matter networks, or something entirely beyond our physics. SETI's foundational assumption that aliens would stick with radio might be as short-sighted as expecting a 22nd century Earth to still rely on telegraphs. This isn't just speculation. Look at our own trajectory. In less than a century, we've shifted from analog radio to fiber optics, lasers, and satellite constellations. If that's the pace of change for a species still in its technological infancy, imagine what a million-year-old civilization might use. The truth is, SETI radio search could be scanning the cosmic equivalent of a ghost town, a frequency band everyone else has long since abandoned. So where does that leave us? If the zoo hypothesis suggests aliens are hiding, we need subtler tools. One promising avenue: hunting for megastructures. Dyson's famous thought experiment proposed that advanced civilizations might build enormous energy collectors around stars, visible through their infrared signatures. Projects like the Glimpsing Heat from Alien Technology Survey have already scanned millions of stars for such anomalies. In 2015, the star KIC 8462852, nicknamed Tabby's Star, made headlines when astronomers observed bizarre, irregular dimming patterns. Some speculated it could be surrounded by a partial Dyson swarm, though dust clouds remain the likelier explanation. Still, the mere possibility proves we can think beyond radio. But megastructures are just the beginning. Other tantalizing clues might lurk in cosmic anomalies, planets with unnatural atmospheric compositions, stars emitting synchronized pulses, or even gaps in asteroid belts suggesting mining activity. The Breakthrough Listen initiative has expanded its scope to include optical and technosignatures, scanning for laser flashes or other deliberate beacons. There's even the wild card of stellar engines, hypothetical devices that move entire stars, which would leave gravitational ripples we might detect. The most radical shift, though, is accepting that evidence might not look like evidence at all. If aliens are actively concealing themselves, their presence could manifest as statistical oddities, patterns in cosmic background radiation, unexplained gaps in exoplanet distributions, or even subtle inconsistencies in the laws of physics as we know them. The Vatican Observatory's brother Guy Consolmagno once quipped that if aliens wanted to stay hidden, they'd simply declare themselves a protected species under intergalactic law. Humor aside, the point stands: absence of proof isn't proof of absence. SETI's real challenge isn't technological, it's imaginative. To find beings who don't want to be found, we must question our assumptions about what counts as a signal. The universe isn't obligated to conform to 20th century human expectations. If we're serious about solving Fermi's paradox, we need to stop listening for greetings and start searching for footprints, the quiet, deliberate marks of those who have mastered the art of invisibility. After all, the best zookeepers don't just watch, they leave no trace. But what if the universe isn't a carefully curated zoo at all? What if it's something far more brutal, a pitch-black forest where every civilization hides, terrified of revealing its location? This is the chilling counterpoint to the zoo hypothesis, Liu Cixin's dark forest theory, a concept from his acclaimed sci-fi series The Three-Body Problem that paints the cosmos as a silent battleground. Where the zoo hypothesis suggests aliens observe us with detached curiosity or ethical restraint, the dark forest imagines a universe where visibility means death. The difference couldn't be starker. One theory sees the stars as a sanctuary, the other as a sniper's alley. Think of Earth's own history. When explorers stumbled upon unknown lands, the outcomes weren't always peaceful conquest. Disease and cultural erasure often followed. The dark forest theory takes this grim pattern to a cosmic scale. Any civilization advanced enough to broadcast its existence risks attracting predators or competitors who'd eliminate them preemptively. In this view, the silence isn't polite restraint, it's survival instinct. The universe isn't a classroom where advanced species mentor younger ones. It's a kill or be killed wilderness where every flicker of light draws hunters. The evidence, or lack thereof, could support either scenario. Fermi's paradox, the eerie absence of alien signals, fits both the zoo hypothesis's hands-off approach and the dark forest's shoot-first logic. But their implications for humanity couldn't be more different. If the zoo hypothesis is correct, our radio broadcasts might be archived in some alien database, waiting for us to mature. If the dark forest is real, every signal we've ever sent is a flare in the night, potentially marking Earth for destruction. Suddenly, SETI efforts to reach out seem either naive or reckless, like shouting into a jungle full of hidden predators. Critics of the dark forest theory point out its cynical foundation. It assumes all civilizations prioritize aggression over cooperation, a view colored by humanity's own violent history. But what if some societies evolve beyond scarcity or conflict? A species that's mastered fusion energy or asteroid mining might have no need to plunder others. The zoo hypothesis leans into this optimism, suggesting advanced beings could value preservation over domination. Yet the dark forest retorts, even one paranoid civilization changes the calculus. It only takes one rogue actor with planet-killing technology to turn the cosmos into a minefield. Here's where the theories collide most dramatically. The zoo hypothesis implies a universe governed by rules, perhaps even ethics enforced by elder civilizations. The dark forest insists there are no rules, only survivors. One is a vision of cosmic parenting, the other cosmic anarchy, and humanity is caught between them, like a child debating whether the dark is full of monsters or just empty space. Neither theory is provable yet, but both force us to confront uncomfortable truths. The zoo hypothesis humbles us, suggesting we're not ready for prime time. The dark forest terrifies us, warning we might never be. Both explain the silence, but one offers hope, the other a Hobbesian nightmare. As we keep scanning the stars, the question isn't just whether we're alone. It's whether we're being watched or hunted. The idea that ancient civilizations might have encountered extraterrestrial observers isn't new, but what if these beings weren't just visitors but caretakers? Ancient astronaut theories, popularized by figures like Erich von Däniken, have long argued that humanity's earliest myths and monuments point to contact with advanced beings. The pyramids of Giza, the Nazca lines, the sudden leap in Sumerian mathematics, these anomalies, the theory goes, defy conventional explanations. But the zoo hypothesis adds a provocative twist. What if these gods weren't merely passing through, but actively managing Earth as a controlled environment? Take the Sumerian tablets, which describe the Anunnaki celestial beings who supposedly descended to Earth to mine gold and genetically engineer humans as laborers. Mainstream archaeology dismisses this as myth-making, but under the zoo hypothesis, the story takes on new dimensions. Could these accounts be garbled memories of alien zookeepers manipulating early humans for observation or experimentation? The parallels are unsettling. Just as modern scientists might tag animals to track migration patterns, an advanced species might have tweaked human DNA to monitor our development, leaving behind myths of divine creation. Then there's the global consistency of certain myths. Cultures separated by oceans and millennia share eerie similarities. Sky gods bestowing knowledge, great floods wiping the slate clean, and instructions to build precise astronomical monuments. The Dogon people of Mali, for instance, knew of Sirius B, a star invisible to the naked eye centuries before telescopes confirmed its existence. How ancient astronaut theorists suggest outside intervention. But if the zoo hypothesis holds, this wasn't random benevolence. It could have been deliberate seeding of knowledge to study how primitive societies process advanced information. Like dropping a calculator into a medieval village and observing the chaos, artifacts only deepen the mystery. The Antikythera mechanism, a 2,000-year-old Greek device often called the world's first computer, contained gears of such complexity that similar technology wouldn't reappear for over a millennium. Mainstream historians attribute it to lost Hellenistic ingenuity, but alternative theories whisper of extraterrestrial influence. Imagine a scenario where alien observers, bound by non-interference rules, occasionally leak advanced concepts to measure human ingenuity. The Antikythera mechanism might not be a gift, it could be a test. Even religious texts reframe under this lens. The Bible's book of Ezekiel describes a fiery chariot with wheels within wheels, a vision some interpret as a spacecraft. In Hindu scriptures, the Vimana's flying palaces battle with weapons eerily reminiscent of modern missiles. These accounts might not be metaphors or hallucinations, but primitive attempts to describe encounters with hyper-advanced technology. If true, the beings behind these visits weren't deities, they were researchers, documenting human reactions to their presence while carefully avoiding full disclosure. Critics, of course, dismiss these connections as wishful thinking, arguing that ancient humans were perfectly capable of invention and storytelling without extraterrestrial help. And they're right, but the zoo hypothesis doesn't require aliens to build pyramids or teach astronomy. It merely suggests they might have influenced the timeline, nudging humanity in ways that left traces in our myths. The real bombshell isn't whether aliens walked among us, it's whether they're still here, watching from the shadows, their presence woven into the very stories we tell about our origins. The unsettling beauty of this idea is its unfalsifiability. Unlike crashed saucers or alien bodies, myths and artifacts are open to interpretation. A zookeeper civilization would know that, leaving clues ambiguous enough to deny but persistent enough to provoke. Whether you see ancient astronaut theories as fringe fantasy or credible hypothesis, one thing's certain: if Earth is a zoo, our oldest legends might be the guestbook. And the keepers, they've been signing it all along. If alien observers are silently documenting humanity's journey, what exactly captures their attention? Unlike anthropologists studying isolated tribes, these hypothetical extraterrestrial researchers would have an unprecedented vantage point, watching civilizations rise and fall across millennia, tracking not just our biology but the evolution of our collective psyche. Picture a galactic version of civilization where every war, invention, and cultural shift is logged in real time. But their focus wouldn't just be on flashy milestones like moon landings or nuclear explosions. The real intrigue might lie in the subtler patterns, how we respond to scarcity, how art mutates across generations, or why certain ideas ignite revolutions while others fade into obscurity. Take warfare as a case study. Human conflict isn't just about territory or resources, it's a fractal of psychology, technology, and chance. An alien research team could be cataloging not just battles, but the underlying triggers: climate shifts destabilizing agrarian societies, propaganda manipulating collective memory, or even the way viral misinformation now sparks violence faster than any ancient grievance. To them, World War II might be a textbook example of industrial age tribalism, while Ukraine's drone warfare represents a new chapter in decentralized combat. The data wouldn't just reveal our destructiveness, but our adaptability, how quickly we turn tools of creation into instruments of annihilation. Art would offer another rich dataset. Imagine alien scholars debating whether Beethoven's symphonies or TikTok algorithms better encapsulate human creativity. Music, painting, literature, these aren't just entertainment, but encoded reflections of our neurobiology and social structures. Cave paintings 30,000 years ago and digital NFTs today might seem worlds apart, but both represent the same drive to imprint meaning onto the void. An observing species could view our art as diagnostic tools, like biologists measuring stress hormones in animal populations. The sudden global obsession with K-pop or the resurgence of vinyl records might signal shifts in collective human needs, tribal belonging in a digitized age, or nostalgia as a coping mechanism for rapid change. Then there's the ultimate variable, climate change. No single phenomenon better illustrates humanity's paradoxical nature, our ability to engineer miracles while ignoring cascading disasters. Alien scientists might see our current era as a pivotal experiment. Can a species recognize planet-wide threats in time to course correct? The 2020s could be their equivalent of watching a Petri dish where bacteria consume their own habitat, except we're the bacteria and we're aware of the doom loop. Do they log our carbon treaties as progress or dismiss them as performative theater? Every failed summit and greenwashing campaign becomes data points in a grim assessment of intelligence versus survival instinct. The chilling parallel is how this mirrors our own study of uncontacted tribes. Anthropologists observe from helicopters or hidden cameras, agonizing over whether to intervene during crises like disease outbreaks. The ethical lines blur. Is non-interference preservation or neglect? Now flip the perspective. If aliens withheld clean energy technology during our climate collapse, would it be to protect our natural development or to see how we solve or don't solve existential puzzles? The Sentinel Islanders have no framework to comprehend satellites watching them. Likewise, we might lack the cognitive tools to recognize extraterrestrial methodologies. Their research papers could be written in neutrino fluxes or quantum entanglement states, utterly invisible to our sensors. Perhaps the most unsettling possibility isn't that they're studying individual facets of humanity, but the connections between them. How religious fervor fuels space programs, how memes topple governments, how droughts birth empires. A truly advanced observer wouldn't see wars, art, and climate as separate categories, but as interlocking gears in the machinery of civilization. Like primatologists noting how chimpanzee grooming rituals reduce troop violence, aliens might be mapping how human rituals, from religious pilgrimages to viral dance challenges, stave off societal fractures. The ultimate question isn't just what they're watching, but why. Are we lab rats in a cosmic sociology experiment, a cautionary tale for younger species, or something more poetic, a rare flicker of consciousness in a silent universe, too fragile to disturb, too fascinating to ignore? Every vaccine we develop, every forest we burn, every symphony we compose could be another entry in a database we'll never see. The greatest twist, if their mission isn't just to observe, but to wait until the day humanity looks up from its own petty conflicts and finally asks with one voice, is anyone out there? That might be the milestone they've been waiting for all along. Quantum entanglement, once dismissed by Einstein as spooky action at a distance, might hold the key to how advanced civilizations communicate without us ever noticing. Picture two particles linked across light years, instantly mirroring each other's states no matter the separation. For humans, this quantum phenomenon is a lab curiosity. For aliens, it could be the ultimate cosmic telephone, a communication network faster than light and utterly invisible to our primitive senses. Here's why this changes everything. Human detection methods rely on electromagnetic waves, radio, lasers, or other signals moving through space at the speed of light. Even our most advanced telescopes are deaf to quantum chatter. Entangled particles don't transmit energy or information in the conventional sense. Flipping the spin of one instantly alters its partner, bypassing the need for signals that could leak into our observable spectrum. It's like having a conversation where the words don't travel between speakers, they just appear. No waveforms to intercept, no traces to track, just silence where there might actually be a galactic internet humming right under our noses. The implications are staggering. Imagine two alien civilizations separated by 1,000 light years. Using quantum communication, they could coordinate in real time, no delays, no static, no risk of eavesdropping from upstart species like us. Human attempts to eavesdrop on alien radio chatter might be as futile as a medieval peasant trying to detect Wi-Fi with a compass. We're scanning the wrong channels because we're trapped in the physics of the past, while advanced societies have moved on to technologies that operate outside our perceptual reach. This isn't just theoretical. In 2017, Chinese scientists shattered distance records by beaming entangled photons from a satellite to ground stations 1,200 kilometers apart, proving quantum communication works on planetary scales. If humans can manage this after a century of quantum research, what could a million-year-old civilization achieve? They might have entanglement relays woven between stars, with nodes hidden in the fabric of spacetime itself. Yet the real genius lies in the secrecy. Quantum signals leave no electromagnetic footprint, no energy dissipates into space, no heat signature betrays their presence. Even if we somehow knew where to look, intercepting the data would require access to one of the entangled particles, a feat as impossible as stealing a letter sealed inside a locked box you can't touch. For a species adhering to the zoo hypothesis, this is the perfect tool. The ability to observe, discuss, and coordinate without the observed ever suspecting a thing. Critics argue there's a catch: quantum entanglement can't transmit usable information without classical signals to contextualize it. But that assumes aliens are bound by our current understanding. A civilization that's mastered quantum computing might have cracked protocols we can't fathom, using entanglement as a carrier wave for data we lack the math to decode. To them, our frustration would mirror a caveman's confusion at a smartphone. The technology isn't impossible, it's just light years beyond their frame of reference. The eerie takeaway: Fermi's paradox might not be about silence after all. The cosmos could be buzzing with conversations we're too primitive to hear, woven into the quantum fabric of reality itself. While we strain our radio telescopes for whispers, entire dialogues might be unfolding in a language written not in waves, but in the silent, spooky bonds between particles. If true, it means the universe isn't empty, just encrypted, and the key to decoding it might lie in a physics we've only begun to glimpse. Suppose extraterrestrial observers have watched humanity for centuries, witnessing plagues, genocides, natural disasters, yet never lifted a finger to help. Is that restraint morally justifiable or an unconscionable abdication of responsibility? This ethical dilemma cuts to the heart of the zoo hypothesis, forcing us to weigh two opposing principles: the sanctity of non-interference against the imperative to prevent suffering. History offers sobering case studies. When European colonizers encountered indigenous populations devastated by smallpox, some debated whether to share medical knowledge, not out of compassion, but to preserve valuable labor. Contrast that with modern doctors administering vaccines in war zones, prioritizing human welfare over political boundaries. Now scale that moral tension to a cosmic level. If aliens possess technology to cure cancer or halt climate collapse, does their silence become a form of complicity? The philosopher Peter Singer's famous drowning child thought experiment resonates here. If you can save a life without significant sacrifice, isn't inaction morally equivalent to harm? Yet there's a counterargument rooted in unintended consequences. Modern conservationists warn against feeding wild animals, not because they lack compassion, but because dependency disrupts natural behaviors. Yellowstone's wolves, reintroduced in 1995, transformed the entire ecosystem by curbing deer overpopulation. What if alien intervention, even with noble intent, unraveled humanity's capacity for resilience? Stopping World War II might have averted millions of deaths, but could it also have delayed the international alliances that later prevented nuclear conflict? The darkest chapters of human history often spur our greatest leaps in ethics and cooperation. The ethical calculus grows murkier when considering cultural contamination. Anthropologists observed how contact with outsiders devastated the Sentinelese Islanders' immunity and social structures. Similarly, introducing advanced alien medicine or energy tech could collapse Earth's economies, religions, and political systems overnight. A civilization that cured all disease might inadvertently trigger overpopulation crises. Ending wars could stagnate technological progress born from military innovation. Like parents watching a child struggle with homework, alien observers might recognize that short-term help creates long-term fragility. But what about existential threats where humanity lacks the tools to save itself? Asteroid impacts, gamma-ray bursts, or runaway artificial intelligence could erase our species entirely. Here, the moral equation shifts. Non-interference risks not just suffering, but extinction. Some ethicists argue that allowing a conscious species to perish when rescue is possible constitutes a unique moral failing, especially if that species shows potential for growth. Imagine aliens possessing technology to deflect the dinosaur-killing asteroid 66 million years ago. Their inaction condemned countless species but permitted mammalian evolution leading to humans. Would sparing the dinosaurs have been kinder, even if it meant we never existed? Star Trek's Prime Directive grapples with this explicitly, forbidding interference even at the cost of planetary catastrophes. But in one episode, Captain Picard violates the rule to save a civilization from an imminent asteroid strike, arguing that blind adherence to principles betrays their spirit. This fictional dilemma mirrors real-world debates about humanitarian intervention. When does the duty to protect override sovereignty? If aliens subscribe to a galactic version of the Prime Directive, where do they draw the line between observation and obligation? The unsettling truth is that morality may not be universal. An alien species with a hive mind might view individual suffering as irrelevant to collective survival. A civilization that mastered synthetic bodies could perceive biological pain as a quaint evolutionary relic. Their ethical framework might prioritize preserving cosmic biodiversity over alleviating temporary discomfort, treating Earth like a nature preserve where wildfires are allowed to burn for ecosystem health. Our appeals for help could strike them as childish demands, like ants begging a park ranger to stop all rainstorms, yet there's a haunting middle ground. If aliens are silently monitoring, they might already be intervening in ways too subtle for us to detect. Perhaps pandemics that should have wiped us out mysteriously burn out, or nuclear close calls involve unexplained malfunctions. The 1983 Soviet false alarm, where Officer Stanislav Petrov single-handedly prevented nuclear war, is often called a miracle, but what if it wasn't luck? The line between non-interference and covert stewardship blurs when the Guardians leave no fingerprints. Ultimately, the zoo hypothesis forces humanity to confront an uncomfortable mirror. Our own history of colonialism, scientific experimentation, and wildlife management reveals how often intervention, even with good intentions, unleashes havoc. Maybe aliens aren't just observing us. Maybe they're learning from our mistakes, using Earth as a case study in the ethics of contact. Every war they allow to rage, every crisis they let unfold, becomes data in a cosmic moral algorithm, one that might someday determine whether we graduate from subjects in a zoo to partners in a far larger conversation. What if climate change isn't just a planetary crisis but a cosmic exam? Under the zoo hypothesis, the greatest challenge humanity has ever faced could be more than a threat. It might be a meticulously designed test, one that determines whether we're worthy of joining the galactic community. Think of it as a final exam for a species still fumbling through its adolescence. Pass, and the invisible observers might finally step forward, fail, and we could remain trapped in cosmic quarantine forever. Consider the parallels in our own scientific experiments. Ecologists studying animal intelligence often create puzzle boxes, complex challenges that test problem-solving skills. A crow figuring out how to use a stick to retrieve food isn't just displaying cleverness, it's proving its capacity for abstract thought. Now flip the perspective. From an alien observer's viewpoint, climate change resembles the ultimate puzzle box. Will humanity leverage cooperation and innovation to stabilize the planet, or will we succumb to short-term thinking and self-destruction? The stakes couldn't be higher. Our response might not just determine Earth's future, it could signal our readiness for a broader cosmic role. The evidence hiding in plain sight is eerie. Unlike sudden, unsolvable catastrophes like asteroid impacts, climate change unfolds at the perfect pace, slow enough to allow course correction, yet fast enough to demand urgency. It's a Goldilocks crisis, not so immediate that it triggers panic, not so distant that it invites complacency. This precise calibration could be intentional. After all, a truly advanced civilization wouldn't test a species with an impossible challenge. They'd design one that pushes boundaries without foreclosing hope. The gradual rise in global temperatures, the escalating frequency of extreme weather, these might not be random misfortunes, but calibrated stressors to measure human adaptability. Here's where the theory gets provocative. Solving climate change doesn't just require technology. It demands global coordination, exactly the skill set a spacefaring civilization would need. Reducing emissions means bridging political divides, aligning economic systems, and sharing technology across borders. These are the same challenges aliens would face when deciding whether to reveal themselves. A species that can't unite to save its own homeworld would be a poor candidate for interstellar diplomacy. The unspoken question behind our warming planet might not be, can they invent cleaner energy? But can they cooperate across tribal lines? History offers sobering precedent. The Cold War's nuclear brinkmanship was arguably humanity's first trial run. The Cuban Missile Crisis forced superpowers to step back from mutual annihilation, proving barely that we could restrain our worst impulses under pressure. Climate change is the sequel with higher stakes and no quick fixes. If aliens are indeed watching, their assessment won't hinge on whether we build better solar panels, but whether we dismantle the zero-sum thinking that keeps nations locked in destructive competition. But there's a darker interpretation. What if failing the test doesn't just delay contact but triggers intervention? Conservationists sometimes relocate endangered species when habitats become uninhabitable. If Earth veers toward uninhabitability, might advanced observers see us as creatures in need of relocation? The ethical lines blur. Would rescuing a select few humans constitute mercy or cultural genocide? And who gets to decide which traits qualify a person for salvation: scientific brilliance, artistic genius, or sheer randomness? The very idea reeks of colonial paternalism, echoing humanity's own fraught history of deciding which lives have value. The ultimate irony: our climate struggle might be invisible to the test givers. Just as we can't detect quantum-encoded alien communications, our planetary crisis could be a non-event to civilizations that mastered clean energy millennia ago. Their version of a test might involve challenges we can't even perceive, ethical dilemmas encoded in dark matter, or societal shifts measured through neutrino emissions. The real exam could be playing out in dimensions we lack the senses to detect, making our fixation on carbon levels as quaint as a caveman fretting over the arrangement of his stone tools. Whether climate change is a deliberate trial or mere cosmic coincidence, one truth emerges: how we respond defines us. If the zoo hypothesis holds, our actions today ripple far beyond Earth. Every policy shift, every technological breakthrough, every act of environmental stewardship becomes a line on a celestial report card. And if the observers are indeed out there, they're not just grading our solutions, they're watching to see if we finally look up from our tribal squabbles and recognize that the only meaningful division isn't between nations or ideologies, but between those who fight for a shared future and those who let it burn. What do gods look like when viewed through the lens of the zoo hypothesis? Ancient texts brim with descriptions of celestial beings descending in fiery chariots, bestowing knowledge, enforcing moral codes, phenomena that sound suspiciously like advanced visitors conducting long-term ethnographic research. The parallels between divine intervention and extraterrestrial observation are impossible to ignore when you examine religious traditions side by side. The Hindu Vedas describe the Vimanas, flying machines piloted by deities who waged aerial battles with weapons resembling plasma beams. The Book of Ezekiel details a wheel within a wheel descending from the sky, emitting thunderous noise and radiant light, a passage so mechanically precise that NASA engineer Joseph Blumrich famously reverse-engineered it as a plausible spacecraft design. Even the Dogon tribe's knowledge of Sirius B, a star invisible without telescopes, suggests either astonishing astronomical intuition or outside instruction. But here's the theological grenade. If these entities weren't supernatural creators but highly advanced scientists, it reframes humanity's entire spiritual narrative. The Judeo-Christian God prohibiting Adam and Eve from the tree of knowledge mirrors a researcher limiting test subjects' access to certain data. The Greek Titans gifting fire to humanity echoes technological transfer between civilizations at different developmental stages. Suddenly, sacred scriptures read less like divine revelations and more like field notes from an ongoing experiment. Where miracles are advanced technology, prophets are contactees, and commandments are behavioral protocols for a controlled environment. Religious scholars recoil at this interpretation, and for good reason. It reduces millennia of faith to a cargo cult misunderstanding of alien anthropologists. Yet the discomfort runs deeper. If Yahweh, Allah, or Vishnu were misinterpreted extraterrestrials, it guts the transcendent mystery at religion's core. Worship becomes a species-wide case of mistaken identity, with prayer as futile as lab rats chanting to their human observers. No wonder theologians like the Vatican's brother Guy Consolmagno cautiously entertain the idea while stressing that scientific explanations don't negate spiritual meaning. After all, if aliens seeded life on Earth, a premise some scientists like Francis Crick seriously considered, does that make them gods or just gardeners? The existential whiplash intensifies when you consider modern reactions. Evangelical circles often conflate UFOs with demonic activity, citing Ephesians 6:12's spiritual forces of evil in the heavenly realms. Conversely, the Aetherius Society blends Christianity with ufology, claiming Jesus was an enlightened alien emissary. Even mainstream religions quietly adapt. In 2021, Israel's former space security chief Haim Esht claimed a Galactic Federation has been waiting for humanity to mature, a statement echoing Kabbalistic concepts of hidden celestial hierarchies. The through line is clear. Whether feared or revered, the idea of cosmic observers forces religions to reconcile ancient beliefs with a universe potentially teeming with higher intelligences. Perhaps the most unsettling twist isn't theological but psychological. Humanity's longing for benevolent watchers, whether gods or aliens, reveals our deep-seated desire to matter in the cosmos. The zoo hypothesis offers a grim trade. We might be observed, but we're also profoundly alone. No salvation, no afterlife, just silent data collectors documenting our struggles. Yet even this bleak view sparks paradoxical hope. If advanced beings once walked among us as gods, perhaps their return isn't rapture, but graduation. The day humanity outgrows its need for deities might be the very day the keepers finally open the cage. Of course, not everyone buys into the idea of cosmic zookeepers silently observing Earth. Many scientists dismiss the zoo hypothesis as little more than an imaginative cope for humanity's cosmic loneliness, a sophisticated version of "the dog ate my homework" to explain why we haven't found aliens yet. The late Carl Sagan, ever the champion of skepticism, famously argued that extraordinary claims require extraordinary evidence. Where, he'd ask, are the alien observation platforms? The monitoring probes, the telltale signs of a galaxy-wide conservation effort. Without physical proof, the zoo hypothesis risks becoming just another modern myth dressed in scientific jargon. The core issue lies in testability. Unlike theories that make concrete predictions like dark matter's gravitational effects or quantum mechanics' probabilistic behavior, the zoo hypothesis is frustratingly unfalsifiable. No matter how thoroughly we scan the solar system or analyze cosmic background radiation, believers can always claim the observers are simply too advanced to leave traces we'd recognize. This heads I win, tails you lose quality makes the idea more akin to theology than astrophysics. As Harvard astronomer Avi Loeb bluntly puts it, invoking undetectable aliens to explain the lack of detectable aliens isn't science, it's storytelling. Then there's the anthropomorphism problem. The entire premise hinges on assuming extraterrestrials would think like 21st century conservationists, valuing non-interference as we do. But why would they? Human ethics are products of our specific evolutionary path: tribal cooperation, resource scarcity, and biological kinship. A silicon-based life form that emerged in a methane sea, or a machine intelligence that transcended biology millennia ago, might find our preservationist instincts as alien as we find the reproductive habits of deep-sea anglerfish. Projecting human motivations onto hypothetical aliens is like ants assuming humans share their obsession with pheromone trails. Occam's razor slices through the zoo hypothesis with brutal efficiency. The simplest explanation for the cosmic silence isn't a grand interstellar conspiracy, it's that no one's out there to begin with. The rare Earth hypothesis posits that while microbial life might be common, the chain of events needed for intelligent life, stable planetary conditions, plate tectonics, a large moon for tidal mixing, could be vanishingly improbable. Even if civilizations arise, the Great Filter theory suggests most self-destruct before achieving interstellar communication, whether through nuclear war, environmental collapse, or runaway AI. The unsettling truth might be that the universe isn't a zoo, it's a graveyard where the tombstones read, went extinct before leaving their solar system. Critics also highlight humanity's chronic pattern-seeking bias. We see faces in clouds, hear voices in static, and interpret random cosmic phenomena as evidence of design. Ancient peoples attributed eclipses to angry gods and plagues to divine punishment. Are modern UFO sightings and Fermi Paradox solutions just secular versions of the same impulse? Psychologists call this agent detection error, the tendency to assume intentionality behind ambiguous events. When SETI Jill Tarter reminds us that absence of evidence isn't evidence of absence, she's right. But it's equally true that absence of evidence isn't license to invent comforting narratives either. Yet even skeptics concede one haunting point: total silence is strange. Statistically, the universe should be buzzing with activity after billions of years of cosmic evolution. Perhaps the truth lies between extremes, not a meticulously managed zoo, but a galaxy where civilizations blink in and out of existence too quickly to overlap. Like fireflies flashing alone in the night, unaware of others doing the same miles away, the zoo hypothesis may ultimately say less about aliens than about us, our hunger for significance in the void, our terror of being truly alone, and our stubborn refusal to accept that the universe owes us neither answers nor audience. The universe is vast beyond comprehension, but does its sheer size make the zoo hypothesis statistically plausible or just wishful thinking? To answer that, we need to dust off a half-century-old equation that's been at the heart of the alien debate since the dawn of SETI, the Drake equation. Dreamed up by astronomer Frank Drake in 1961, this deceptively simple formula attempts to calculate how many communicative civilizations might exist in our galaxy. Plug in the numbers, and suddenly the abstract idea of alien zookeepers transforms into a game of cosmic probability. Start with the basics. The Milky Way contains roughly 100 billion stars, with an estimated 1 to 2 planets per star in the habitable zone, those Goldilocks regions where liquid water could exist. That's 200 billion potential Earths right there. Even if only 1% of those planets develop life, and 1% of life-bearing worlds spawn intelligent species, we're still looking at 20,000 civilizations scattered across the galaxy. Suddenly, the idea of a few advanced societies designating Earth as a nature preserve doesn't seem so far-fetched, but here's where the variables get messy. The Drake equation includes terms like L, the average lifespan of a communicative civilization, and this is the wrench in the gears. If most civilizations last only a few centuries before wiping themselves out, say, through nuclear war or climate collapse, then the galaxy might be a graveyard of extinct cultures, not a bustling interstellar community. On the other hand, if even a handful of societies survive for millions of years, they'd have ample time to establish observation protocols. Imagine a single civilization 10 million years older than ours. They'd have witnessed Earth go from dinosaur-dominated to human-inhabited, with enough time to debate whether we're worth contacting. Recent exoplanet discoveries add fuel to the fire. We now know rocky worlds like ours orbit at least 20% of Sun-like stars. Kepler 442b, for instance, sits firmly in its star's habitable zone and receives sunlight similar to Earth. Planets like this could be prime real estate for civilizations far older than ours. Factor in the 13.8 billion-year age of the universe, and it's statistically likely that some societies had a multi-billion-year head start. For context, if the universe were a 24-hour clock, humans showed up in the last 2 seconds, plenty of time for others to have set up galactic zoning laws. Critics counter with the rare Earth hypothesis, which argues that complex life requires an improbable chain of cosmic coincidences. A stable star, a protective gas giant like Jupiter, plate tectonics for climate regulation. Even if microbial life is common, intelligent observers might be vanishingly rare. But here's the twist: rarity could actually support the zoo hypothesis. If Earth is one of just a handful of life-bearing jewels in the galaxy, advanced civilizations might treat us like a protected species. After all, we don't build wildlife preserves for cockroaches, we build them for pandas. The Fermi Paradox resurfaces here with brutal elegance. If the galaxy should be teeming with life, where are the construction projects, the Dyson swarms? The interstellar traffic jams. The zoo hypothesis offers a chilling resolution. Absence isn't evidence of emptiness, but of discretion. A crowded galaxy might look silent because its residents have mastered the art of invisibility. Like a safari guide wearing neutral tones to avoid startling the animals, advanced civilizations could be deliberately avoiding the cosmic equivalent of bright colors and loud noises. But let's talk timescales. Human civilization is roughly 12,000 years old, a blink in cosmic terms. A species a million years ahead wouldn't just surpass our technology, they'd transcend our very understanding of observation. Their monitoring tools could be woven into the fabric of space-time itself, quantum sensors in Earth's mantle, neutrino detectors in the sun's core. We wouldn't recognize their surveillance any more than a butterfly understands satellite imaging. The ultimate takeaway: math alone can't prove the zoo hypothesis, but it shreds the assumption that aliens would inevitably announce themselves. The numbers suggest a galaxy where civilizations could be abundant yet invisible, choosing silence over disruption. Whether that silence is born of ethics, indifference, or something far stranger remains the greatest equation left unsolved. Oumuamua wasn't just another space rock, it was a cosmic curveball that left astronomers scratching their heads. When this interstellar visitor streaked through our solar system in 2017, it defied all expectations. Unlike typical asteroids or comets, Oumuamua exhibited bizarre properties. Its elongated, cigar-like shape, unexplained acceleration as it departed, and the absence of a visible coma or tail. Harvard astrophysicist Avi Loeb controversially suggested it might be artificial, a probe or solar sail from an advanced civilization. While most scientists lean toward natural explanations, the mystery endures. What if Oumuamua wasn't a random traveler, but a deliberate exhibit in Earth's cosmic zoo? A fleeting glimpse of alien technology, designed to pique our curiosity without revealing too much. Then there's the enigma of crop circles, those intricate geometric patterns that materialize overnight in fields worldwide. Skeptics rightly point to hoaxers with planks and ropes, but a stubborn subset of cases resists easy dismissal. The 1991 Barbury Castle formation in England, for instance, displayed a fractal pattern of unprecedented complexity, its precise mathematical ratios aligning with sacred geometry. Eyewitnesses reported strange lights preceding its appearance, and soil samples from genuine sites show microscopic changes inconsistent with human tampering. If these aren't all pranks, could they be celestial breadcrumbs, artistic provocations left by observers testing human perception and interpretation? The wow signal adds another layer to this puzzle. Detected in 1977 by Ohio State's Big Ear radio telescope, this 72-second burst of radio waves matched the expected signature of an extraterrestrial transmission. Coming from the Sagittarius constellation, it was never replicated despite decades of follow-up searches. The signal's brevity and singularity fit a disturbing pattern, tantalizing hints just credible enough to spark debate but never conclusive. Like a zookeeper rattling the cage bars to observe the animal's reactions, these anomalies might be calibrated to keep us questioning without ever providing answers. Contrast these with unambiguous hoaxes. The 1957 Ubatuba UFO debris in Brazil, purported to be extraterrestrial magnesium, was debunked as military scrap. The 1989 Gulf Breeze UFO photos were exposed as clever double exposures. These cases serve as valuable filters, reminders that amid genuine mysteries, human deception thrives. Yet the existence of fakes doesn't negate the outliers that defy explanation. The scientific method demands we separate signal from noise, and the zoo hypothesis thrives in those liminal spaces where noise refuses to fully obscure the signal. Perhaps the most unsettling takeaway isn't whether these phenomena are alien in origin, but how they mirror humanity's own methods of indirect observation. Marine biologists use decoy cameras disguised as rocks to film shy octopuses. Primatologists leave fruit puzzles in jungles to assess ape problem-solving. If extraterrestrials are studying us, wouldn't they employ similar techniques, placing enigmatic objects in our path to gauge responses? Oumuamua pass by, crop circles transient beauty, the wow. Signals one-off blip, these could be cosmic Rorschach tests, revealing more about our capacity for wonder and skepticism than about their creators' intentions. The true test lies in how we respond. Do we dismiss all anomalies as hoaxes, risking intellectual blindness, or do we chase every UFO claim, risking credulity? The middle path, rigorous scrutiny tempered by open-mindedness, might finally unravel whether we're truly alone, or merely the latest subjects in a galaxy-spanning observational study. After all, in any zoo, the most fascinating behaviors emerge not when the animals notice the watchers, but when they begin to suspect they're being watched. Humanity stands on the precipice of becoming an interplanetary species, but what happens when we take that first irreversible step off Earth? If the zoo hypothesis is correct, our push toward Mars colonization could trigger something monumental, the moment our cosmic caretakers finally break their silence. After millennia of passive observation, watching us stumble through wars and breakthroughs, aliens might view a thriving Martian settlement as humanity's graduation day, proof we've evolved beyond our cradle and are ready for a seat at the galactic table. Consider the precedent we've set with our own conservation efforts. When endangered species like the California condor or black-footed ferret rebound enough to leave protected habitats, scientists celebrate not just for the animals but for the restored balance they represent. Now reverse the lens. If Earth is a planetary ark under alien stewardship, our successful expansion to Mars could signal we've reached a sustainable level of resilience. No longer fragile infants prone to self-destruction, but a civilization capable of safeguarding its own future across multiple worlds. That achievement might be the threshold the Watchers have been waiting for. Space exploration itself could serve as the ultimate test. The challenges of surviving on Mars' radiation shielding, closed-loop ecosystems, interstellar resource management aren't just technical puzzles. They're proxies for the kind of cooperative problem-solving required to join a hypothetical interstellar community. A Martian colony demanding global collaboration mirrors the unity needed to engage with alien civilizations peacefully. The observers might interpret our ability to sustain life beyond Earth as evidence we've outgrown tribal conflicts and short-term thinking, the very behaviors that could make us dangerous galactic neighbors. History offers sobering parallels. When isolated societies like Japan's Sakoku era or Tibet encountered outside technological civilizations, the results were often catastrophic. But when cultures met as relative equals, like the mutual exchange between Islamic and European scholars during the Middle Ages, progress flourished. An advanced species might withhold contact until we reach a baseline where interaction wouldn't devastate our social fabric. Mars becomes that benchmark, proof we've developed the technological sophistication and cultural maturity to weather cosmic culture shock. Yet there's a darker interpretation. Expansion could be perceived as a threat, just as wildlife rangers cull invasive species that disrupt ecosystems. Alien observers might see human colonization as a risk to cosmic equilibrium. Our track record of ecological domination on Earth driving species extinct, altering atmospheres, could mark us as reckless terraformers in their eyes. The first Martian city might not garner applause but containment protocols. Instead of welcome parties, we could face orbital quarantines or stealthy sabotage of our life support systems. After all, no zookeeper releases a predator without safeguards. The technology we develop for interplanetary survival might itself become the trigger. Fusion reactors, atmospheric processors, or quantum communication breakthroughs could inadvertently replicate tech the galaxy considers restricted. Like tribesmen suddenly reverse engineering rifles from colonial outposts, our innocent innovations might violate some interstellar arms control treaty we never knew existed. The moment our Mars-bound ships cross a technological threshold, perhaps achieving 10% light speed or mastering antimatter harvesting, could be the moment hidden monitors switch from observation to intervention. Or perhaps the truth is subtler. Contact might not come as a dramatic announcement, but as gradual, deniable hints, anomalous radio pulses from Phobos, two perfectly placed mineral deposits, or even leaked schematics for warp drives found buried in Martian ice. These would allow cautious engagement while letting humanity save face, maintaining the illusion of discovery rather than the shock of revelation. The Watchers could engineer a slow disclosure, letting us believe we're pioneers right up until the moment we realize we've been handed training wheels. The ultimate irony, our Martian ambitions might already be influenced by unseen forces. The sudden convergence of billionaire space rivalries, governmental moon-to-Mars programs, and exoplanet discovery fever could reflect external nudges, social engineering on a civilizational scale. Like lab rats pressing the right lever without knowing who built the maze, we may be following a script written in gravitational waves and quantum probabilities. When that first seedling sprouts in a Martian greenhouse, the keepers of the zoo might finally step from the shadows, not as invaders or saviors, but as admissions officers holding our long-awaited acceptance letter to a university whose existence we never suspected. One thing is certain: the moment humans establish permanence beyond Earth, we transform from subjects to participants in the cosmic experiment. Whether that transition brings celebration or containment remains the universe's most tantalizing unsent message. What if Earth isn't just a research station, but the universe's most fascinating reality show? Picture a civilization so advanced that science has lost its novelty, where unraveling the mysteries of physics is as mundane as solving a child's puzzle. For beings like these, observing humanity might not be about data collection but pure entertainment. Think of how we binge-watch nature documentaries, captivated by the drama of predator and prey. Now flip the script: our political scandals, artistic revolutions, and even viral internet trends could be their version of must-see galactic television, with Earth as the ultimate unscripted drama. Artistic motives add another layer. Consider how humans preserve vanishing cultures through photography or oral histories, not for study, but because their uniqueness moves us. An alien species might see Earth's kaleidoscope of cultures as living masterpieces, too beautiful to disturb. The haunting melodies of Tibetan throat singing, the intricate geometry of Islamic mosaics, the explosive colors of holy festivals, these could be cosmic works of art, preserved in a galactic Louvre where humanity is both the painter and the paint. There's precedent in our own history. The 19th century romanticists who idealized noble savages weren't anthropologists, they were aesthetes seeking inspiration from untouched ways of life. Could aliens be our universe's romantics, keeping Earth pristine for its cultural poetry? Nostalgia offers the most poignant possibility. Imagine a civilization that evolved beyond biological form, their emotions digitized or discarded. Watching humans might evoke memories of their own primal past: the taste of food, the sting of heartbreak, the irrational joy of dancing in the rain. Like retirees flipping through yellowed photo albums, these beings could cherish Earth as a living relic of experiences they've long outgrown. The way we maintain colonial Williamsburg or samurai villages wouldn't be so different, preserving not just artifacts, but the messy, emotional essence of a bygone era. The tourist angle is equally compelling. Earth's biodiversity alone would make it a galactic bucket list destination. From bioluminescent bays in Puerto Rico to the otherworldly geothermal vents of Yellowstone, our planet boasts wonders that could dwarf the sites of 1,000 exoplanets. Advanced civilizations might have strict ethical guidelines against interference, not out of respect, but to maintain the authenticity of the experience. Just as eco-tourists pay premiums to see undisturbed wildlife, alien visitors could value Earth precisely because it hasn't been spoiled by cosmic contact. The occasional UFO sighting, merely tourists pushing the boundaries of their non-interference vows, like safari goers tempted to toss a snack to the lions. Yet the darkest twist is voyeurism. Humans have a grim history of treating the vulnerable as spectacles, from freak shows to poverty tourism. If Earth is the galaxy's equivalent of a zoo or a Truman Show, then our suffering becomes part of the appeal. Wars, pandemics, and natural disasters might draw larger viewer numbers than our triumphs. This isn't just speculative, our own media proves the allure of conflict. Reality TV thrives on manufactured drama, and true crime documentaries monetize tragedy. An alien audience could be equally drawn to the raw, unfiltered stakes of real survival, watching with the same detached fascination we reserve for ant colonies flooding or meerkat territorial battles. The truth might be a mosaic of all these motives. Just as humans visit national parks for science, scenery, and self-reflection combined, alien observers could have multifaceted agendas. One faction studies our neuroscience while another admires our architecture. Some revel in our soap operas while others mourn the fading of our analog traditions. This plurality of purpose would explain the inconsistent nature of potential contact, why some encounters feel clinical while others reek of pageantry. Ultimately, these speculative scenarios reveal less about aliens than about us. Every motive we project onto hypothetical watchers is a mirror of our own virtues and vices, our capacity for awe and exploitation, our hunger for connection, and our fear of being insignificant. Whether the universe hosts documentarians, artists, or cosmic rubberneckers, their silence forces a haunting question. If we're someone else's entertainment, does that make our lives more meaningful or just more absurd? The answer might depend on whether the show's producers ever intend to let the stars meet the audience. If the zoo hypothesis is real and advanced civilizations are quietly watching us, humanity has homework to do before we're ready for the cosmic spotlight. The first step isn't about building flashy tech or decoding alien signals. It's about getting our own house in order. Global unity isn't just a lofty ideal. It's the bare minimum requirement for interacting with interstellar societies. Right now, Earth looks like a chaotic dorm room to outsiders' nations squabbling over borders, corporations hoarding resources, and half the planet scrolling while the other half struggles for clean water. To graduate from cosmic toddlers to galactic peers, we'd need to demonstrate something radical: the ability to act as a single, coordinated species. The United Nations Office for Outer Space Affairs already has protocols for first contact, but they read like instructions for handling a stray cat. Avoid sudden movements, don't feed it strange objects. What's missing is a framework for proving we've evolved beyond tribal divisions. Imagine aliens asking, "Who speaks for Earth?" and realizing we don't have an answer. Establishing a planetary ambassador role, backed by a unified council with representatives from science, philosophy, and indigenous wisdom, would be a start. The European Union's transition from wartime enemies to a cooperative body shows it's possible if painful. The key difference: we'd be negotiating under the gaze of observers who have seen civilizations far older than ours rise and crumble from infighting. Ethical frameworks matter just as much as political ones. Before shaking hands with extraterrestrials, we'd need to confront our own track record. How we treat AI, animals, and even each other could be scrutinized like an interstellar background check. SETI post-detection protocols focus on verifying signals, but say nothing about how to answer if aliens ask. Why should we trust a species that still wages war over ideology? Developing a shared moral code, one that transcends cultural relativism, would force us to reconcile everything from genetic engineering to climate justice. The irony, preparing for alien contact might require solving problems we've ignored for centuries. Transparency would be non-negotiable. Any clandestine arms race or corporate space grab could sabotage first impressions. The Artemis Accords governing lunar exploration are a tiny step toward accountability, but we'd need full planetary disclosure. No hidden nukes, no classified bioweapons. Picture an alien version of a home inspection where they scan Earth and find both the Mona Lisa and nuclear silos in the same timeline. Our saving grace might be demonstrating capacity for change. Finland's transformation from a war-torn nation to one of the most stable societies could serve as a model. Evolution isn't about perfection, it's about trajectory. Language barriers present another hurdle. Math and physics might serve as universal starting points, but conveying concepts like human rights or humor requires nuance. The Linkos project, a conceptual language designed for interstellar communication, combines logic and pictograms, but we'd also need to anticipate cultural blind spots. Dolphins communicate in sonar clicks rich with emotional context we're only beginning to grasp. How much more might we miss with beings who think in quantum probabilities or experience time non-linearly? Investing in xenolinguistics now, rather than after first contact, could prevent catastrophic mistranslations. Perhaps the most urgent preparation has nothing to do with aliens at all. Healing Earth's ecosystems would signal we've moved beyond predatory expansion. A civilization that can't sustain its own biosphere has no business venturing into galactic society. Costa Rica's reforestation and Denmark's circular economy prove rapid environmental turnarounds are possible. To observers, restoration efforts might matter more than rocket launches. The difference between a species maturing versus one burning through resources like a teenager maxing out credit cards. Above all, we'd need to cultivate intellectual humility. The assumption that aliens will share our values or communication styles is dangerously anthropocentric. Indigenous wisdom traditions like the Maori concept of Kaishiakitanga guardianship might better resonate with extraterrestrial ethics than Silicon Valley's "move fast and break things" mantra. The very act of preparing for contact could become humanity's final exam, testing whether we've learned enough to join a community we've only just realized exists. The universe might not care about our GDP or Instagram followers, just our readiness to step beyond the cage we didn't even know was there. Science fiction has long been a playground for exploring the zoo hypothesis, often disguising profound cosmic questions as popcorn entertainment. Take Arrival, the 2016 film based on Ted Chiang's story of your life. On the surface, it's a first-contact thriller about linguists decoding alien symbols. But beneath the stunning visuals lies a chilling subtext. The heptapods aren't just visiting. They're orchestrating humanity's evolution, gifting us a language that rewires our perception of time itself. Their motives remain opaque, their methods gentle yet inexorable. This isn't invasion or salvation, it's custodianship, a nuanced portrayal of advanced beings intervening just enough to steer us toward a predetermined future. The film's haunting beauty lies in its ambiguity. Are these aliens benefactors or curators of a cosmic garden we can't yet comprehend? Childhood's End, Arthur C. Clarke's classic novel pushes this further. The overlords arrive not with fanfare but with quiet authority, dismantling human conflict while withholding their true purpose. Their watchful presence mirrors the zoo hypothesis's central tension, benevolent supervision that edges toward paternalism. Clarke's genius was recognizing how unsettling utopia can feel when imposed from above. The overlords' refusal to reveal their form until humanity is ready echoes real-world debates about cultural contamination, forcing readers to ask, is ignorance the price of peace? Then there's the Twilight Zone's iconic episode, To Serve Man. What begins as a hopeful allegory about alien generosity twists into one of television's most devastating reveals. The titular book isn't a manifesto for cooperation, but a cookbook. The twist works because it inverts zoo hypothesis logic. Instead of observing from afar, the Canamites exploit humanity's naivety. The episode's enduring power comes from its warning: not all watchers are passive. Some might see Earth not as a preserve but a pantry. Even children's media wrestles with these ideas. Avatar: The Last Airbender frames the spirit world's relationship with humans as a delicate balance between intervention and detachment. The spirits aren't quite aliens, but their parallels to hypothetical observers are striking: capricious, ancient, and endlessly debating whether humanity is worth nurturing or abandoning. When Ong bridges both worlds, it's less a victory than a graduation, mirroring the zoo hypothesis's central question: what milestones must a species reach to earn cosmic recognition? The Marvel Cinematic Universe offers a popcorn-flavored take with Guardians of the Galaxy's Celestials. These planet-sized beings treat civilizations like lab experiments, judging societies worthy of survival or annihilation. Their godlike indifference isn't just narrative spectacle, it's a blockbuster metaphor for the ethical vertigo of the zoo hypothesis. When a celestial pauses to spare a world, is it mercy or merely a change in research parameters? What makes these stories resonate isn't their special effects, but their uncomfortable questions. They condition audiences to consider that contact might not come with soaring music and handshakes, but with silent scrutiny. An idea that's migrated from fringe science to mainstream consciousness. When Arrival's Louise Banks asks, "What is your purpose on Earth?" and the heptapods reply, "There is no time," they're not dodging the question. They're reframing it entirely, suggesting that humanity's obsession with motives might be as quaint as ants puzzling over highway construction. The cultural impact of these narratives is measurable. Pre-Close Encounters, UFO lore fixated on abduction and invasion. Post-Arrival, polls show growing public openness to non-threatening contact scenarios. This shift reflects fiction's power to prime real-world expectations, not by predicting the future, but by expanding the range of possibilities we're willing to entertain. When astrophysicists like Avi Loeb speculate about Oumuamua's artificial origins, they're speaking to audiences already conditioned by decades of nuanced sci-fi to consider stealth observation as plausible. Yet for all their prescience, these stories share a blind spot. Few explore how observed civilizations might detect their watchers. District 9's stranded aliens or aliens' ruthless xenomorphs are emphatically present. The true terror and fascination of the zoo hypothesis lies in its elusiveness. The most accurate depiction might be Solaris, where the planet's sentient ocean studies humans through grotesque recreations of their memories. Not with clarity, but through a glass darkly, a mirror held up to our own inability to perceive what truly watches. This storytelling gap highlights our deepest anxiety, that the cosmos isn't just silent but indifferent. Fiction that grapples with the zoo hypothesis from arrival to childhood's end ultimately serves as cultural coping mechanisms. They let us rehearse for revelation, whether it comes as enlightenment or existential shock. Because if there's one thing these narratives agree on, it's that first contact won't look like we expect. It'll force us to question whether we were ever truly alone, or merely the last to know. The zoo hypothesis remains one of the most tantalizing and unsettling explanations for Fermi's paradox. It threads the needle between science and speculation, offering a chillingly elegant answer to the cosmic silence. We're not alone, just overlooked. Whether framed as a galactic nature preserve, an ethical experiment, or a reality show for advanced beings, the theory forces us to confront the possibility that humanity isn't the main character in the universe's story. We might be the subjects of a study we didn't consent to, living under the gaze of observers who have mastered the art of staying hidden. But here's the twist: the very lack of evidence becomes the hypothesis's strength. Unlike theories that rely on detecting alien megastructures or radio signals, the zoo hypothesis thrives in the absence of proof. It suggests that advanced civilizations wouldn't just be silent, they'd be undetectable by design, operating beyond the limits of our perception. The eerie consistency of UFO sightings that never quite deliver proof, the uncanny timing of scientific breakthroughs that feel like nudges, even the way our own conservation efforts mirror the theory's logic, all of it dances on the edge of plausibility without ever tipping into certainty. Critics dismiss it as unfalsifiable, a cosmic, just-so story that explains everything and nothing. Yet the hypothesis endures because it speaks to something deeper than astronomy, our existential anxiety about insignificance. It's the ultimate mirror, reflecting our fears of being both watched and ignored, revered and irrelevant. Whether the universe is a silent graveyard or a crowded zoo, the question remains the same: are we truly alone, or is something out there waiting for us to grow up? Now it's your turn. What do you think? Is the zoo hypothesis a brilliant solution to Fermi's paradox, or just a sci-fi comfort blanket for a lonely species? Drop your thoughts below, because if there's one thing we know for sure, it's that the universe loves a good